Hello, this is Mrs. Brett. I am going to show you how to study for your exam. I know it's kind of challenging, so I want to make sure that we do it together. The first thing that I want to talk about is numbers 1 and 2. We've already gone over those. You should be able to show your calculation. It's really important that you always show your calculations when you are asked to do that. If you don't remember what the pressure equation is, your notes are here. It's called Pascal's principle. It's equal to the force divided by the area. One thing that is missing in here is the units, and I'm going to go over that on the study guide notes. Okay. The next thing, we have a hydraulic system. This is when you are taking a look at how much it multiplies. So it's important that you understand whenever you're doing a comparison between two things that are the same, like here we have a force and we're getting another force, what it's looking for is a ratio. And whenever you are calculating a ratio, it's one thing over the other. Here it's asking you how much it multiplies. So how much force from here, you have 1,700 pounds going in. How much more force are you getting when it comes out on the end? You have 6,800 pounds. Your ratio is actually not the difference. It's going to be equal to one of the forces over the other force. Okay, so you have, and when you want to do this correctly, what you do is you do your output force, force out, over your input force, force in. Let's make that a little bigger. Okay. And if you take a look, once you're done with that, you notice that we actually have some numbers. We have two forces, which is great. So we can just substitute it in. We have 6,800 pounds. And we're going to be putting that over 1,700 pounds. And when you get all done with that, you plug it into your calculator. You notice that you get 4. Please be careful. This is one of those times where your number really will be naked, because when you divide a pound by a pound, it's just like dividing 4 by 4. Anytime you divide anything by itself, you get 1. So 4 times 1 is still 4. This is a force multiplier, and it multiplies the force 4 times. So whatever force you put in to your input, you'll get 4 times more for the output. Okay. That said, this is asking you what type of multiplier it is. So there's two things here that it's asking you to do. Your multipliers are things that we have built. We built a force multiplier, in our robots. It looked very similar to this right here. We used 2 syringes. A piston is basically the plunger part, okay? So maybe you want to make a highlight and say, okay, piston Sorry, I can't talk and type at the same time. So whenever you see the word piston, what it means is the plunger on the syringe. And that's the part that you're pushing and pulling, and that's the part that's moving. You have 2 different types of multipliers. You have a force multiplier, and that is something that takes a smaller force, like 1,700, and turns it into a bigger force, like 6,800. You also have a distance multiplier, and this is how we analyzed our systems for our robots. We said, okay, if we're pushing in 2 inches here, what are we getting on the other side? So when you set it up so that you have smaller movements, creating bigger distances on the other side, that's called a distance multiplier, because it's multiplying the distance without using a lot of effort. That said, this here is a force multiplier. So that's a relatively simple one. All right. Unfortunately, when I started typing, number 3 went down. This one right here is technically not a force multiplier because it's not really multiplying the force. All it's doing is changing the direction, but I'm not sure that you're going to be worrying about that. So we'll call this one a force multiplier as well. And the age-old example, when you spin these little pedals right here, It's a very small movement and you get to go flying down the street. So that is a distance multiplier. And those are two different types of multipliers that you will need to be able to identify. I am not going to review pneumatic and hydraulic systems. I feel like almost everyone has an excellent handle on those things. The one mistake I was seeing when grading this was most people were not giving me examples. If you don't have examples, what you need to do is make sure that you go back and you take a look at some of the examples here. All right, so these are open and closed systems, but some of them are hydraulic and some of them are pneumatic, and you should be able to talk about those different types of systems. So please review those notes for hydraulic and pneumatic as well as open and closed systems. Again, be careful giving examples of each. That said, I'm going to stop this video because I want to make this a separate section. So this is stuff that you were familiar with or was very easy to catch up on. I'm going to make a study guide as well, but for right now, let's stop this and move on.